Good morning, everyone. I am going to give a brief about the helical and horn antennas. This is a practical shape of the helical antenna, the simple and practical configuration of electromagnetic radiator, and that is a conducting wire. It is wound in the form of the screw thread forming a helix. Screw thread forming a helix. In most cases, helix is used with the ground plane. This is the ground plane. This is the ground plane. See, this is the geometry of the helical antenna with the ground plane, and this is the feed wire, and this is the coaxial cable, and the helix is made of copper. The wire bent like this. Uh, one is for the ground plane, that is a flat shape. The diameter of the ground plane should be at least the 3 lambda by 4. The ground plane can be like flat shaped, or it can be the cupped in the form of the cylindrical cavity or frustum cavity. There are two types. One is a cylindrical cavity, and the second one is the frustum cavity, and another one is the ground plane is in the form of the flat shaped. It is connected to the center of the conductor of the coaxial transmission line at the feed point of the coaxial cable. With the center conductor of the line is attached to the ground plane. Coaxial cable center connector is connected to the ground plane. This is the another form of the ground plane, flat ground plane. Turning space between the turning space, and this is the diameter of the wire, helix diameter, and this is the ground plane. Main geometry and the operation of the helical antenna: ground plane, coaxial feed, and height. H is the height of the antenna. See, diameter. This is the diameter, and see the circumference of one turn of the helix. That is the pi d. D is the diameter, pi d is the circumference. This is the vertical spacing between the turns of the helix. That is between any two spacings of the helix. S is the spacing between the turns of the helix. It is common for each and every turn of the helix. Alpha is the pitch angle. Alpha is the pitch angle that is mainly controlling the pattern antenna of the helix, and it is increasing the direction of the Z. And alpha pitch angle is equal to tan inverse S by C, and alpha n is the number of turns, and total height of the antenna is H is equal to N into S. If you have height is H, N is the number of turns, S is the spacing between the vertical separation of the helical antenna. When alpha equal to 0, then the winding is flattened. That is, when alpha equal to 0, winding is flattened. Helix is becoming the loop antenna. Helix is becoming the loop antenna with the n number of turns. Or if alpha equal to 90 degrees, the helix is becoming a linear wire antenna. When alpha is in between the 0 to 90 degrees, then it is called as the helix antenna. That is, in between the 0 and 90, it will be called as the helical antenna. Generally, the radiation characteristics of the antenna can be controlled by the geometrical parameters compared to the wavelength. The input impedance also depends upon the pitch angle and the size of the conducting wire. This is the radiation pattern of the helical antenna, general helical antenna, which is bidirectional like this. See, this is the length of one turn. This is the diameter. This is the one length of the total length of the one helical wire antenna. S is the spacing. 2a is the wire diameter. 2a is the wire diameter. D is the diameter of the helix. 2a is the diameter of the wire. There are two modes of operation. One is the normal mode and the other one is the end-fire mode. Helix operates in these two modes. Helical antenna. The axial mode is that is also called the end-fire mode, and the another one is the normal mode or broadside mode. In the normal mode, the mode of operation, the field irradiated by antenna is maximum in the plane normal to the helical axis, and minimum is along the axis. For the normal mode, it is the name is the normal. It is maximum along the normal to the direction of the helix, and the to get the normal mode of operation, the dimensions of the helix usually very small compared to the wavelength. That is, L lambda naught, NL naught is less than lambda. The diameter of the helix is also reduced to loop when the diameter is d and pitch angle approaches to 0. Whereas in the other case, this is the end-fire mode. End-fire mode, in this one, the radiation pattern is maximum in the direction of the radiation, in the direction of the radiation, in the axial mode. In this one, the helix must be within the 3 by 4 less than c by lambda less than 4 by 3 range, that is c by lambda equal to 1, approximately c by lambda equal to 1, and the pitch angle is in between 12 to 14 degrees. In pitch angle is 12 to 14 degrees. Another types of feed, that is waveguide and dielectric rods also possible in this axial mode of operation. Next we will see the basic horn antennas. What are the different types of the horn antennas? See, this is the basic horn antenna. This is waveguide and it is flared out at the ends of the waveguide. That is, if the waveguide is flared in both the directions, then it is pyramidal horn antenna. If it is flared in only E plane, then it is called the E plane horn antenna. If it is flared in H plane, that is called the H plane horn antenna. This signal is bidirectional. It will emanate from horn mouth and it will receive the signals from the horn mouth. It is invented in the year 1800s and mainly it is in operation in active from 1930s. It is the mostly used microwave antenna because it is operating in high frequencies and it is can withstand for the larger powers. Because it is a flared waveguide that produces nearly uniform phase front larger than the waveguide. Waveguide is only flared at the ends of the waveguide. The construction is also have the different shapes. One is sectoral H plane, pyramidal and conical horn antennas. This is mainly used as a feed element for the parabolic reflector. The common element is it is applicable for phased arrays, and you can have the universal standard for calibration and also for gain, standard antenna for calibration and the gain, and it is mainly used for making electromagnetic interference measurements. These several applications are there. These are some of the applications for the horn antenna. The main concept of the horn antenna is this may be considered as the RF transformer or for the impedance matching between the waveguide feeder and the free space, because free space has an impedance of 377 ohms. Because it is tapered or flared at the end of the waveguide, it is formed which gives the impedance to be matched. How much we are flaring at the ends of the waveguide, we get the impedance matching. It also helps to suppress the waves traveling via unwanted modes in the waveguide from being radiated. That is, unwanted signals can be avoided by using the this antenna. Gain levels are balanced between upper size and length depends mainly for the gain, and we will get the gain up to 20 dB. There are pyramidal horn and sectoral horn and in the pyramidal horn it is a rectangular shape and normally used with the rectangular value. Whereas sectoral and it is one type of or one pair of sides only flared while other the remains parallel. That is if it is the E-plane sectoral and only E-plane direction only it is flared out. H-planes will not be flared out. The form of configuration produces a fan-shaped beam which is narrow in the plane of the flared sides but wide in the plane of the narrow sides. You can see the structure of E-plane and H-plane antennas. See, this is the E-plane horn antenna. This is flared in the E-plane direction, that is the vertical direction. That is flared in the direction of the electric field or E field in the waveguide. Whereas H-plane horn antenna, it is flared in the H-plane or H field direction of the waveguide. Conical horn antenna, this is having the circular cross section. It is for circular waveguide is flared out to get the conical horn antenna. See, this is the E-plane. This is how the electric field is produced. This is flared in the vertical direction. This is the E field, so E-plane have sectoral antenna. This is the H-plane is the horizontal direction. This is flared in the horizontal direction. So the beam is in the vertical and here the radiated beam is the horizontal. Pyramidal in both the directions, E-plane and H-plane, both the directions are flared out. This is the conical horn antenna. This is the circular waveguide. It is flared in the circular fashion. That is the conical horn antenna. These three are the rectangular waveguides flared out. This is the circular waveguide flared out in the form to form the conical horn antenna. This is the ridge waveguide. That is two ridges are placed for the pyramidal horn antenna at the center of the waveguide. This is giving the more robustness for the horn antenna. This is the dimensions of the pyramidal antenna. You can see the waveguide and this is the flare and this is the signal going in the forward and backward direction. See this is the radiation pattern, how it is emanating or radiating from the horn antenna, radiating from the horn antenna. Maximum in the direction of the beam or mouth or aperture of the antenna. See, this is the radiation pattern of the E-plane sectoral antenna. Maximum power is in this direction, along the direction of the mouth of the antenna or aperture of the antenna. This is the practical structure of the horn antenna flared out in both the directions. See, for rectangular horn antenna, the aperture E, that is the width of the aperture in the E field direction, that is square root of 2 lambda LE, and aperture H equal to square root of 3 lambda LH. For conical horn antenna, diameter is equal to square root of 3 lambda L. Here aperture E means width of the aperture in the E field direction, aperture H is the width of the aperture in the H field direction, L is the slant length of the side in the E field direction, LH is the slant length of the side in the H field direction. Diameter of the D, the diameter of the cylindrical horn aperture. L is the slant length of the cone from the apex. Lambda is the wavelength of the signal. The gain horn antenna gains are the gain for the pyramidal horn antenna over the isotropic source, which is radiating in all directions equally, gain equal to 4 pi A by lambda square A. A is the aperture efficiency and the figure of merit between the 0 to 1. For conical horn, the gain formula is pi D by lambda whole square A. A is the physical area of the aperture, D is the physical diameter, lambda is the wavelength. The main advantage of horn antenna is it is not a resonant structure, so it is giving the wide bandwidth and the construction is also easy. Only thing is either rectangular waveguide or cylindrical waveguide you have to flared out in the either E direction or the H direction. And it is easy to interface with to the waveguides because waveguides the two waveguides can be connected easily together. Thank you.